Hello, my name is Aaron Benjamin Gamandanker from EE.
Hi, my name is Ashraf Shazan bin Fairuz from EE.
Hi, my name is Muhammad Iqmal Amir bin Muhammad Aziz from Electrical and Electronics Department.
My name is Muhammad Ahmad Shafi.
Hi, my name is Junyan from EE.
Hi, my name is Muhammad Shafuddin from EE.
Today, I'll be briefly explaining about the article that we have critiqued, entitled Evaluation of Solar Energy Potential in Malaysia. The study was done to evaluate the potential of solar energy generation specifically at 3 locations in Malaysia, which are Pontian, Kerteh, and Teluk Intan. In this study, the authors used a software called Homer software, which stands for Hybrid Optimization Model for Electric Renewables. The findings show that Pontian generates the most electricity annually due to the usage of large PV panels for its system. However, the cost of energy produced is the highest amongst the 3 locations. While Kerteh received the highest solar radiation and can manage to fulfill its energy demands despite using smaller PV panels. Kerteh is found to have the lowest energy cost out of the 3 places that were studied.
Homer software is a tool that can simulate hundreds of systems with variables that cannot be controlled, such as wind, speed, and fuel costs. The authors use it to generate different possibilities of PV system by accounting into solar irradiance and PV tenor cost factors. This is a good software and suitable to be used in this study, as other researchers like Saad et al. And Lajimi and Gold have also incorporated this software in their research.
However, a simulation can only do so much. Although detailed figure and variables can be displayed with all the appropriate system that can be done in a practical way, it is not as simple as that. The PV system to be set up, we need to consider the terrain. For example, what if the terrain was not flat? Or what if the area is surrounded by trees and foliage? Moreover, the study never mentions that it considers certain environmental or atmospheric conditions like humidity or mechanical stress. These factors should be considered as they determine the degradation of the PV system. In hot and humid conditions, moisture can permeate the PV modules and separate the cells from the metal, thus enhancing corrosion and allows for the leakage of current. By accounting into these factors, economic analysis can be rendered inaccurate. This is because extra maintenance and repairs may be need to measure. Furthermore, the study relies inputs and variables from other articles to do the simulation. If the values are outdated, especially from older articles, then they are unreliable for present use. Hence, a separate real-world trial of the PV system needed to be done. For instance, Saad et al. Performed the same simulation and also a real-world trial of the research. By doing so, a more complex and in-depth methodology and variable can be explored and analyzed.
This study, to simulate how much power will be used, the author suggests that the 3 locations follows the same power distribution as 100 houses village or 100 houses in the rural area. These situations, however, are incorrect and will give lower values as compared to real-world power consumption. Additionally, the load usage for different types of areas are distinct from one another. Housing areas, urban areas, and industrial areas needed to be separated by category, like low, medium, or high consumption. By doing so, the PV system implemented can truly be tested whether it is suitable or not. By biasing the energy consumption towards residential areas only, the author cannot conclude that it can be represented that the 3 locations as a whole. It is said that lamps, a TV, a fridge, fans, and a washing machine are the most common appliances that can be found. These are correct, but however, the author failed to include smaller power-consuming appliances such as chargers or other small electronics into the study. Although it may not seem much, but gradually over time, it can add up to a substantial amount of electricity consumption.
So this study actually does not provide enough data for its evaluation. We cannot actually conclude whether the power generated by the simulated system is efficient enough or that it is actually consistent throughout the year. In the study, while they do mention the energy generated by the system monthly, they don't actually stress upon it. The only thing that they consider was the overall annual energy generated. Another researcher, Salihin et al., performed a similar study, but a practical one. They found that out of the 12 months in a year, only 6 of the months could actually meet the energy demands. Salihin et al. Determined that the power generated by the system was not enough to support the energy demands consistently throughout the year. Therefore, what about Aziz et al.? The data and evaluation therefore is insufficient, as the system should be evaluated instead on the monthly energy demands. Therefore, the data and evaluation by Aziz et al. Should instead consider the monthly energy demands, as the demands will be variant, as well as the power generated. Furthermore, due to uncertain weather conditions, it is highly unlikely that the system will actually produce constant or consistent power monthly.
Other than that, the authors evaluated the economic feasibility of the system. Battery contributed to most of the costs, which are 58% of the total cost. In 2011, the Feed-in-Tariff system was introduced in Malaysia. This allows for electricity consumers to generate, use, and export net energy back into the grid. Thus, this system should be taken into account instead of a standalone PV system used by the authors, which can be economically inefficient. Cost of installing and the maintenance of the battery can be reduced. By doing so, the solar energy system can be more appealing to users to consider as a clean alternative for energy.
To conclude, we can say that the study was unsatisfactory as there were several issues that was neglected. Although Homer software is a useful tool in planning, we should also consider real-world elements such as terrain and atmospheric conditions. The input and variable may not be up to date as they are sourced from older articles which can render the results. Moreover, the research was biased towards one group of consumers, which was used to represent the tree location as a whole. Furthermore, the results lack clarity whether the power generated can meet the needs of power consumptions. Lastly, it was determined that standalone PV system was not optimal as feed system. For future studies, we recommend that the Homer software should be tailored and specialized according to Malaysian climate. Next, consider doing both simulation and real-world tests to have better judgment on the results. The test should also be done several times until the software is adjusted to a constant value. Lastly, a physical test would be a cheaper option rather than planning a wide-scale simulation, and appropriate testing could also be derived.